All right, from the plasma frontier, here's Fraz Frazzle with our next exciting installment. Take it away, Fraz.
Thank you, Cleve. Today we're going to proceed on with GANS. This will be the second in the series. Basically, I'm expecting all of you who are reading or watching this video to have a basic knowledge of GANS production, how to make it. You should by now have already produced the CuO, the CH3, the CO2 GANS. Preferably, you've done one of the GANs of water, which is either seawater or the salted water or the Oramus. So these are kind of the skill sets I'm hoping and you really do need to go on to this next step. That was your beginning GANs stuff, which is learning how to make it, temperatures and that type of stuff. We are going to go on to a little bit more advanced in the nomenclature. In the next advanced GANs that I'll be doing, we'll be looking at the dynamic interactions of GANs, and this is to return the nanoplasma state of GANs back into the matter state. And for a teaser, you guys could go back and actually review Knowledge Seekers number 32, which is available on the web, and that'll give you an insight to what we'll be talking about in a future video. But for right now, we're going to review. I'm going to share the screen, and I'm going to start with nomenclature. It'll take a second for everything to come up. Okay. This is out of my notebook, and basically we have three columns. The one on the left says the name. In this case, we're using CO2 as the name. It'll be set up kind of like in a beaker on the left-hand side. The next column, which says gas and liquid and GANs, that is your state, what state it's in, and that has a designator of gaseous, which would be above the liquid, aqueous, which would be the liquid, which is usually the clear portion of your GANs. This is also known as structured water. For those of you from different backgrounds and looking at it, this would be the structured water. It'd be a different kind of structuring water, but we're structuring water in that one. The bottom, which is the sediments, the stuff in the bottom, is the nanostate, the monoatomic. The next column over says pH, and in the gaseous form, we really don't have a way of measuring pH. In the aqueous state, it can either be plus or minus, which is alkali or acidic. And in the nanostate at the bottom, of course, that's fairly liquid still in most cases, unless you try it out. And that's going to be a pH plus or minus also. Down at the bottom in the fourth column over, it says subcategory, and you'll see /M and /G. And this is by definition magnetical leaning or gravitational leaning for the GANs. Your GANs are very similar to your Van coils, even though we say they're magnetical or gravitational. To be more specific, we should say that they're gravitational leaning or magnetical leaning, meaning that if you change their position or you change a little bit on them, you might change that state, whether it's magnetical or gravitational, especially in the coils. Run this up a little bit. The next row, I've got, let's see if I can expand it up a little bit more. There we go. A way of writing it, the nomenclature, so it makes a little bit more sense. At the top one, it's CO2, and at this time we were using a circle around the lowercase g, so it was CO2 in the gaseous state. This would be similar that if you had the sippy cups and you had the zinc and the nano copper on the outside, or just the zinc and the nano zinc on the outside of it, and you were inhaling the gas from inside the sippy cup through a soda straw, this would be the gaseous form of the CO2. You go down into the aqueous, and we're calling it plus, meaning that it's alkaline, and it's in the aqueous solution, it's in the water solution. You can also have zinc oxide out of the same creation, and it'd be ZnO, and that's usually a heavy. And the others is like, for example, copper oxide would be a minus in the aqueous, and the CH3 would be a minus in the aqueous. The next row down is CO2 with a plus, because it's still in that category in the pHs, and it's in the nano state, and it would be magnetical because it's the lighter of the two GANSs in your mixed GANs of zinc oxide and CO2. Alongside it, or below it, when you do your separations, you would have zinc oxide, and that would be a plus, and because it's a nano state, the white powder at the bottom, and it would be G, gravitational, because it was just heavier, and that's simply by definition. Your copper oxide would be a CO minus, because it's still in that pH factor thing. In the nano state, it would be a /G gravitational, because it's very, very heavy. What's interesting when we get into the CH3 is that it is in, a lot of times when we harvest the GANs, it's both in the magnetical and the gravitational, and I'll show you an example of that in a little bit. Now, since there was problems with getting a circle onto computers with letters on the inside, we've gone into simple brackets. So it's like, you know, a bracket around the NG or the NM in that notation. So we have evolved a little bit on our gravitational. You have two more categories in GANs. You can be in the, when we're down in the nano state, and both the magnetical and gravitational can be either a paste, and we use the letter P as in pigs, or dry, the letter D as in dog. And this comes into play later on because sometimes we need to use a stickier form of GAN, so we want it in a paste form. It's simply just removing some of the water out of it. And then dry is basically dry and be able to ship it without having to worry about things slopping. And so that's basically, in a nutshell, the ideas behind the nomenclature and why we've gone to this. Hopefully, as we go through this video, you're going to see where this makes a lot of sense and is very necessary. Stop sharing. When we go to, let's take a quick look at different GANs while I've got them in my hand. A CH3 in more of the hemoglobin style. Let's see if I can get a little light on this. Show up a little better. It has an orange to reddish color. It's lightweight. It's called magnetical. It's very light and fluffy. What's interesting is when we slide a magnet over the top of it, it doesn't move. So CH3, even though it's an iron-based GANs, is not magnetical in this stage. It doesn't follow a magnet. You can run a magnet up and down on it all day, and it's not going to change any. Grab the magnet real quick. In fact, I can see if we can. It just doesn't a magnet just doesn't affect it at all. Okay. When we go to CH3, which would be gravitational CH3, this has been washed. And when we run a magnet over it, as you can see, it follows the magnet. This is very cool stuff. And for what we'll be using it for, this property is super important. Okay. This is one of 2 Ganses that I've found that actually will be attracted to a magnet. The other one's the neodymium because it has quite a bit of iron in it already, and we'll show you a little bit of neodymium in a minute. For the car units, you're going to need about 1.5 cups of the heavies, of the CH3 gravitational. And this is washed to get the salt out of it. And it's had the magnetical stripped off the top. And there's 2 ways of doing it. And I highly recommend on the CH3, when you go to separate the heavies, that you have an inverted Coca-Cola bottle or pop bottle with a tube through it that you're making your Ganses. And the tube is like a piece of surgical tubing or flexible tubing that you can crimp off or put a clamp on it. And siphon the heavy part, the gravitational, off from the bottom, from the very, very bottom, and put that into a separate container. What am I meaning? I'm going to show you this Gans. And you see that there's quite a bit of the gravitational, or magnetical, I should say, magnetical CH3 at the top and the gravitational at the bottom. And there's a demarcation, a line in the middle of it. We see it not quite as distinct per volume with the CH3 producers. This is neodymium, and there's actually neodymium, which is the rare earth mixed with the iron, and it's a programmable magnet, and the steel, which has the iron in it. So you'll end up with a distinctly mixed Gans when you do neodymium. But you'll also see that same separation to a lesser extent with your CH3. In future videos, we'll be recombining these after they've been separated out into their heaviest and their absolute lightest forms. So, bear with us. We're teaching Gans right now on how to do it. For the lights portion, which would be the magnetical on this one, I would use either a pipette, for those of you in the chemistry stuff, in industry, a pipette. You can use an eyedropper and siphon it off the top. A turkey baster works too, it's a little more crude. And you suck just the light orange. You're going to leave a little bit at the bottom in that line that's in between them, I should say. And your heavies you subtract off the bottom if you possibly can. You could run your turkey baster clear down into the bottom and suck it up from the bottom, but you have a tendency to stir, and you'll end up with a lot more of the magnetical in it, and it's just a process of sorting and sifting through it using water and your rinses. But you want to get your in the case of the car units and the flight units and the power units, you're going to want to get the heavies, the gravitational portion, as pure as you can or as clean as you can. It won't be 100% with the facilities that most of us have. You're not in a scientific lab where you can do spin separation with a centrifuge or something like that. But just same way as the gold miners do, we're going to be basically washing our Gans, separating the lights from the heavies, and working it out that way. For the car units, you're going to need about 1.5 cups of the CH3 minus Ng. For the dynamic cores, you're going to need between 1/2 cup and 3/4 cup. of the CH3 NGs. The next thing that I want people to think about when they're processing their GANs is, how do we tell what the pH is? And the simple way is basically some test strips, and they're available anywhere. They're really inexpensive. And the instructions say you just dip the strip into the liquid and read it from, match the colors on the back. And this one actually tests 3 different properties of water. The thing is do not dip this into your whole jar of GANS water. You're going to contaminate it with all the test material that's on it. So what you're going to do is, after your water has been structured, it's been sitting there and everything's settled out, pour a little bit of that off into a clean cup or a clean glass and measure your pH separate in that small amount rather than in your entire solution. And I cannot stress this strong enough and long enough and hard enough. Don't pollute your GANSs with your testing. Okay. When we start cleaning our GANSs, when we start rinsing them, for most of my GANSs, I use distilled water. And the reason for that is there isn't hardly anything else in it except water. That's all it is. There's no chlorine, there's no iron, there's nothing. It's just, some people say dead water. It's just sitting in the bottle, ready to take on information and stuff and wash the stuff. It salts the stuff out. I cannot stress the next point strong enough, and you'll hear me do it several times. Never, ever use municipal city water that's been treated for washing your GANs. There's too much chlorine in it. There's fluoride in American systems. There's a lot of iron and other trace elements. And for all intents and purposes, don't use it for your GANs. It's not a good product. Okay. Let's see that one. When we get into the next one, which is Gans of Urine, it has the appearance of CO2. It's a little bit off color. It'll have a tint to it. It's made basically with urine with caustic added to it. You could bump up it a little bit if you wanted to put a little more salt in it, sodium chloride. Be careful of what type that you're using. You're going to change the properties of it. We're actually looking more so in the build of flight systems of strictly using your urine. And it'll be the person that's going to be in charge of the space flight, lift-off, takeoff, direction, that type of stuff. It's your direct tie to your lift engine. And this is why we're releasing the information, and we're telling you that, no, we can't build it for you, because it needs to have your controls in the very, very center of the unit. And I'll bring up the chart in just a second. We go into the CH3 for the flight systems next. And that's the one that I showed you that the magnet pulls the liquid up. Now you can use distilled water for that one also, but at least on the last rinse, and I'm going to be very specific with this, you need local water, not city water, either from a pond or a lake or a stream or a river. And it's even better if it's water that you've consumed in the past sometime. It's part of your makeup. I don't recommend using well water. Well water comes clear from the inside of the earth down in the aquifers. And when we rinse the last time with our GANs, our CH3 GANs, we're going to want to use this surface water for the simple reason we're building the inside of the control units to be representative of you. And the CH3 will have the hemoglobin, which is produced with a piece of iron in the CH3 generators. That helps produce that nice reddy orange color, sometimes as much as almost a red. A lot of times we're going to recommend for this one that you actually put a little bit of your blood in there. And with your local water, this is your communication back home. This is kind of like Dorothy when she goes into Oz and wants to return back to Kansas. She clicks her heels together 3 times and says, "There's no place like home, there's no place like home." With the Starship units, you have to have a return that says, "I want to go home now." And home is imprinted in everything of the core of your Starship engine. It's in your urine, it's in your blood, it's in your CH3, it's in your local water. And why I said I'm not really certain I want you to try the well water is that home may be for that particular water origin down in the earth, in the aquifer. And so we don't want you returning underground, we want you returning to the surface of the earth. And that's as far as we've figured out the navigation system on the flight units. But at this point, from what we understand about structuring water through prayer, yes, by all means, pray over your GANs. Structuring it with water off the surface of where you reside, what is home for you, yes, very, very important. And there'll be links in the notes below to Schellberger's information and some more on structuring water. It's super, super important. Okay, in the car unit, I'm still thinking that you're probably going to want to use your local water, your surface water from around your area, for either from a stream or from a lake or from a pond, a river. But once again, never ever city water on this one, and that's for washing your CH3 at the last minute on, before you put it in your car units. Your urine GANs, or the PP GANs, most of the time it's distilled water that we're using to wash it with. You'll notice quite a bit of odor coming off the first couple of washings. It reeks of ammonia pretty bad. After you get it pretty well washed out, it's kind of got an earthy smell to it. It's not bad at all. And this is kind of like your lymph of your system. This one, you may also want to use your surface water locally to do that final rinse before you put it into your Starship flight system. Anyway, why is all that notation important? When we go to put the GANs into our structure, let me pull up a diagram. I'm going to go to this is the inside of the dynamic core. It's kind of the part of the static core. And then I'm going to notate this center down the middle. That's your antenna. That square on the outside, which is blue, that's the 1/4 inch PEX that we talked about in the last video. And at the bottom is your lead GANs in the bottom. Our different places have different GANs in them, and you have to make certain that you put the right one in the right place. In the center, right next to the antenna, inside the 1/4 inch pecs, it's this area right there, is going to be your Gans of Urine. PP plus, it's the nano stuff at the bottom, the white Gans, the fluffy stuff, which makes it a little more magnetic. And you're not going to need a heck of a lot. The tube is really small. Inside there, this tube, besides the Gans of Urine, there's going to be 1 grain of caustic, no more than that, and a small amount of aluminum foil. And then just a small aluminum bead foil, just barely big enough to, so it's small enough so it'll fit inside alongside your antenna wire, your copper antenna wire. And that one gets basically sealed up. And it's very important because you're going to start from the inside and work your way out. Clear all. Your next layer, which is the copper pipe, sits out further, and there's that coil of copper wire, the primary on the inside. That's where your soda cap bottle, the Joey cap down there, seals the bottom in, and it's all glued and stuff in. What goes in here is your CH3 minus, and then parentheses, it's going to be nano, which is N, slash gravitational. And that's going to be a wash gravitational that's in, let me get another color, purple. And that's going to go in and around between that piece of PEX and the copper on the inside. This inside that copper, 3/4 inch copper pipe. You'll notice that the pH, clear all, is PP plus, is alkali on the very center. But the next one out is the CH3, and it's a minus. And we're going, in our progression of Ganses, when we go to select them, you're going to have plus, next to minus, next to plus, next to minus, or going from one to the other so that you have a gradient that one feeds the other. There's a difference in the charges, and this facilitates your electrical charge as it passes through the system. Your nano coating does a lot. Your different dissimilar metals does a bit more. Your GANS is one of the multipliers. And so each time it goes past one of these changes, be it a different form of GANS or a different pH or a different state, you set up a difference in what that GANS does for your circuit. And so you keep your progression in order, and you're not doing collisions like a minus to a minus and plus to a plus in the progression. Then you're going to get a better tumble of the plasmatic fields. And we're using the heavy states, clear all, in the center. These are going to be gravitational dominant, in the bulk on the inside. The center down the middle, let's do it. The center down the middle is going to be color negative. And so as you're progressing out, this first part of the GANS though, in the large amount, and that's the CH3, is the ferrite, ferrite core of the system. This is basically where we give and take electrons really free, and it's got lots and lots of surface area because how small the iron particles are in that GANS. There's the surface to volume ratio per each particle is much, much greater than the fins and stuff you see in your motors on your ferrite cores, these conglomerate ones. GANS is a wonderful thing on the inside of your dynamic cores. We also look at going from the nano state to an aqueous state, and you'll have your nano state on the inside of the copper pipe. What you lace your maggrav or your outer cores is going to be the aqueous GANS, the bracket A. And so if possible, if really possible, if we do everything right, in the very center, we produce H3 in the gaseous state. I'd be so happy if that's possible. We're doing everything we possibly can to get that phenomenon to happen. So we have H3 basically on demand, constantly being put out. That's what the little bit of aluminum bead, Gans of Urine, a little grain of caustic inside the plastic tube is all about, is the gaseous state. So you've got a matter state of the Gans of Urine interacting with the gaseous state. So it'd be like matter state, from magnetic state to gaseous to nano state, which would be the CH3, to the aqueous state, which is in the top, would actually be the CH3 in the aqueous state on the first level on the flight system. And then you go to the different forms. And if you've got if there's a confusion of which way do you go, you look for the different one. If you know that you've got to use two that are similar, like an aqueous to an aqueous, you go from one GANS that is either a strong alkali or a strong to a strong basic, or alkali acid to a strong, from a strong acid to a strong alkali, or backwards, the other way, or from a magnetical leaning GANS to a gravitational leaning GANS. So this is just some of the things that you play with. You look at whether you're on the magnetic portion of your maggrav coils or the gravitational. When we get into the flight systems, the gravitational is going to be the inner wire going through it, and the magnetical is going to be the outer wire. So it's going to be virtually impossible to soak the whole thing in a GANS and get it right, because you're doing two different functions in the same coil. So we may need to think about isolating the inner core wire of the gravitational by some kind of protective coat so it doesn't interfere with the nanocoating of the magnetical, which is on the outside of it. In this case, you would have two distinctly different coils, not a leaning one, but what I'm saying is the inside of a single coil of a maggrav or a flight system, the inside coil is going to be gravitational. The outside spring coil around it is going to be magnetical. In your stacker units, you have two sets of two springs, where the inner set of two is gravitational leaning, and the outer set is magnetical leaning, meaning that each one of them has a gravitational component to them and a magnetical component to them. It just happens to be that where they're located in the circuit, one becomes dominant gravitational and the other becomes dominant magnetical. And these are some of the things that you have to think about playing with. And this is where the nomenclature comes in really, really handy when dealing with GANSs. So you know which ones to use, where, and why. The systems that we're putting together in this stage, which is more advanced of the GANSs has to do with the intent of what you're building. And you're trying to align your intent with the end product. You're trying to align all the components from the inside out to the same intent. When it comes to the flight systems, whoever ship it is, whoever is in control of the dynamic core, the flight engine portion of it, needs to know the system inside and out, from the very inner part of the antenna system all the way out through the lift coils on the outside. Every part, every pathway that the plasma travels under, whoever is operating that ship has to know it, because you're controlling the function telepathically. And in some of our next coming videos, I'm going to bring in some people who will explain telepathic control of flight systems and what it entails. It's a little more complicated than what the average male on this planet thinks. We have like 6 or 8 different emotions, and that's about it. A well-trained pilot may be looking at as many as 360 different emotions, so that you can pinpoint exactly destinations and angles and what have you, whether you're going up, down, sideways, the rotations and that type of thing. So keep this in mind. And review real quick. For most of your GANSs, you're going to be using distilled water to wash them. I want you to think about separating the heavy portions from the lighter portions, so that you have extremely magnetic leaning GANSs and extremely gravitational leaning GANSs. I want you to think about where you're going to collect your water for the final rinse and imprinting of the circuitry. You know, is it going to be a lake? Is it a stream? Are these things that you want in your spaceship? What's ever in it? The purer the water, the better, but it needs to be someplace that is local to you and is familiar, and it has heavy emotional ties, so that when you want to come home, you can come directly home. Do not use city water. It has too much other things in it, like chlorine, mercury, hopefully not, fluoride, any type of industrial waste that water has traveled before it got to the water treatment plant. When I was living in Iowa, it was said that the water we drank in Iowa from the sources on the Mississippi River had gone through at least 3 humans prior to reaching us. That's how many people were consuming water along the Mississippi River. I think that was maybe a stretch, but it got you to think about what all that water has gone through before it gets to you. At least it went through several fishes and otter and, you know, a duck or two and along the way, and maybe a cow. So the fresher the water is in the line of good drinking water from a surface source, the better. I know a lot of you don't have that choice, so you do the best you can. But I still strongly recommend staying away from the municipal water for these units. Your distilled water is not going to have that good of a imprint of your home love area. There's some work that could be done in the line of prayer and structuring, and I may let Cleve talk a little bit. I'll put him on the spot right now and see if he's got any good thoughts at this point. And any thoughts, Cleve?
Gee, thanks for the notice.
I know.
Well, there's a lot of information by scientific research and of course all the esoteric type people as well. But you know, as you say, water has a memory. It's a living crystal. if you've not made yourself acquainted with the properties of water, and none of us are taught at school or in the system really what water is, you need to get online and check out people like Victor Schauberger, and there's quite a string of others. There's that Japanese professor that froze water after people put emotional thoughts towards the water. And it remembers, as you say, until it's reprogrammed. Usually on Earth, it's through the rain cycle. Is the first time is where it gets its memory cleared and reprogrammed. So water has a lot of properties that you need to acquaint yourself with, and it's particularly relevant to what we're dealing with plasma energy. It's all connected with intention and the subtle energies.
Okay, very good, thanks.
Yeah.
I'm going to jump in real quick. We're going to go over one more topic. I just realized that I'd missed it on my notes. And I've got my gloves on, and this is your lead GANs. And what we're going to be looking at is, for the container at the bottom, is the white GANs at the bottom. If you don't have enough, you can use some of the liquid. Okay, this is fairly, when you go to make it, wear protection in the line of gloves and stuff. Try not to get it on your hands. It is lead, and until I see any studies coming forward, I consider this toxic material. But we got to have it. I don't have any other GANSs that will fill the space where we need it, especially in the wireless transmitters for indoors, receivers of electricity. I don't have anything else that will work at this point. And for the spaceship, you're going to need a temporary, a non-earth ground or an artificial ground, and that's what the lead provides. So this is, yes, make it. Please handle it carefully. Don't be throwing it away on the ground. One of the comments on the other video was you could make it without salt, and the more I thought about it and I went back and tried it, the salt isn't necessary. You can use 2 pieces of lead as your anode and your cathode. You can set up your variable power supply, and you can get it to produce lead GANs rather quickly at 0.03 amps. And this means that you could do it with your 1.5 volt to 3 volt batteries with a LED in the middle of it between the 2 wires, and it will produce your lead GANs pretty efficiently. Thoughts between the other GANSs. For the spaceship copper oxide GANs, I'm looking, CuO, I'm looking for a deep turquoise color. If it is a light blue, light sky blue, a pasty white blue, you've got quite a bit of zinc oxide probably mixed in. That usually happens when you're using current. On the spaceship CuO GANs, we are looking for that deep turquoise blue in color, and a lot of times this is done without any added current to it. Your CO2 GANs, what do I do with it? There it is. A lot of times when you're using current, you'll get a GANs that has this color to it. It isn't just white at the top and a powdery white at the bottom. You'll actually see this black in there, and that is part of your zinc metal. It's a crystalline zinc, from what, as close as I can tell. Basically, this can be washed and separated just like any of the other CO2 GANSs. The lights come off and you'll actually see it. I would like you to take your GANs from your CO2 generators and do the separation and watch your volumes, because your true CO2 will be cloud-like, And that's the solution here. And moves around very, very similar to a cloud. And that's completely washed just about, except I've got a little bit at the bottom, not too bad. But anyway, this is part of the separation. This is on the second wash on this. The zinc oxides against this. Now, your other Ganses, yes, we went into, over the past year, a lot of us went and did Ganses of many other metals and items. For the electrical system, for the Starship, basically you're going to stay with the basic four. You have copper oxide, your CO2, your lead GANs, and your CH3s in both forms. So it'll look like you have actually 5 different Ganses by the time you get everything separated out. And I think this is as far as we could get to multiplying to doing the multiplier of the effects of the GANs when added to our rings until we can figure out another way to make it stronger. And Joe sent a link to acoustic separation, and I'll have that listed at the bottom in our notes. Once again, we are independent research and development innovators, and we could use your support. So there's a donation button at the bottom, and we hope you enjoy this, and we're working very hard to get the rest of the blueprints out and the rest of the teaching instructions. We've come a super long way in 2 months, and we'd like to share it all with everybody. So hang in there. We're doing as much as we can, as fast as we can. Any comments, Cleve, as we close this one up?
Yeah, I'd just like to say my urine PP GANs is darker than yours.
Maybe because you got, a little problem with the kidneys and the bilirubin. I don't know.
No, I never added any salt at all to mine.
Okay.
It's a little bit tanner, it's browner. As far as the teaching...
You may find when you wash... Yeah.
No, go.
I was going to say, maybe if you wash it again, it might not be so dark.
Now, as far as the teachings go, again, excellent, and you're covering a lot of new ground for a lot of people, because you don't hear this about a lot, the separating the Ganses and such, except from you. So, and it's all about gradients and understanding all that. So, kudos, you've you've given us more stuff to think about, and I know it's just another step down the roadway, and there's a lot more information that you've already recorded to come out, and
right.
I encourage people to just keep tuning in and just think about it a bit, and it won't be long before they're building machines that are doing everything that they want from them. So thanks very much, Fraz.
You're welcome. Patrick, I'm going to call on you. We're going to be interviewing Patrick here in one of our upcoming videos. Might as well introduce him right now. He's had experience with car units. Patrick, go ahead and turn your video on and your camera on and say hi to everybody.
Hello.
Any questions, Patrick? You're coming in late on some of this stuff, but...
Yeah, no, it's very, very informative, and I'm finding that I've got a lot of catching up to do, and if I review and review and review, it'll come to me. But it's all very clear.
Am I correct, Patrick? You're the one that had the big plastic bucket full of balls of GANs?
Yes, everybody's been watching my balls.
Yeah. As you lead them around like Mother Duck around the pond.
Yes, yeah. It's actually really quite interesting what what ganses interact with each other, and we can learn a lot just by simple little experiments. And yeah, it's
the reason I brought the reason.
Sorry.
Yeah, the reason I brought that up is it was quite influential in my understanding of how important the different GANs were to watch your tub of floating spherical balls interact with each other plus you. And that's where I went, you know what? There is something to this intent and the mindfulness and the mind control of these. And so hats off to you, kudos to your observation, and
thank you,
the plasma world of innovators here really thank you for that particular video.
Yeah, thank you, Fraz. Look, it really is quite fascinating, and I did say at one stage that one of the balls jumped clear out of the water, and while I didn't see it do it, I saw it jump out of the corner of my eye, and I certainly heard the splash, and I saw the ripples that it made. So I found it very interesting.
Yes, and we'll, as we go further in the spaceship portion of our talks, we're going to be talking about that rill formation. Not only does it happen on the surface of water, it happens in the time-space continuum too. So it's a very interesting observation. We're very thankful that you pointed it out and showed everybody. So,
yeah, cool.
As I enjoy bringing in some of the pioneers of the plasma frontier, and the ones that said, wait a minute, I see something, and it is reproducible. It's not something that is just something that I dreamt up and tried on and off on. Well, this is actually something that everybody can do. And Joe will be bringing...
Well, this is how planets stay in formation. Our solar system has all of these field interactions, and it's when we do simple little experiments like that that we can see that that the moon is adhering to its orbit around the Earth, and the sun and Mercury, and it in our own way we can create these little interactions that model what we can see in the sky. And yeah, it's fascinating. So,
alrighty, thank you much, and we're going to wrap it up today. Please check notes at the bottom. We'll have several links, and I think I'll see if I can talk Patrick into sending him a link to his video with the balls in the water.
no problem.
Thank you. Good day. Thank you, and good day.
Thank you.